Hello, I'm Fram, the brother from California.
And I'm Greg, the serious brother from New York.
And I'm Geoff, the brother they brought in to boost the ratings.
And today we have a special guest with us, by the way, Geoff. I think we're going to get the ratings boosted even better. We have with us Brenda Discher from Siemens Digital Industries.
Does this mean we have to adopt her as our sister?
We never had a sister. So yeah, she'll be the much younger sister, Brenda.
Okay.
Wow. I don't know if I'm going to boost the ratings. I think the camaraderie is already pretty contagious. It is a pleasure to be here, Fram and brothers 1 and 2. I look forward to sharing and talking about batteries, I guess, is our subject today, Fram.
Batteries is our subject. And, I think we've talked a lot about electrification and how electronics are going into everything. And of course, a key part of electronics is energy, and how do you get energy to run these electronics? So, Brenda, why don't you kick us off here? Give us your initial thoughts on batteries.
Yeah, so the way I view it is there's always competitive pressure to differentiate products, but the urge to tackle climate change concerns is actually driving a bigger boom in this whole sector, right? And the whole idea of electric mobility, charging, transportation charging, energy storage, it's changing the landscape in our country, but kind of globally. And the whole e-mobility sector is just fueling the demand for safe, for sustainable, for cost-effective, for more energy-dense and fast-charging batteries. And so this is a market that I believe is going to have explosive growth. But really, I think between commercial, government, and even academics, we're going to need to rethink how we actually innovate in this market.
Yeah, and so, you bring up the market. I looked at some statistics. It looks like today it's about $100 billion industry, double-digit growth. People are talking about by 2030 that this could be almost $500 billion industry, right? And growing rapidly. And you talked about innovation, and of course, when I think about innovation and the brothers think about innovation, we go straight to the semiconductor industry. So, Geoff, Greg, your thoughts on this?
No, I think that's a really great analogy, Fram. As I did some background research on this industry, there are a lot of parallels with the early semiconductor industry. Clearly, as Brenda indicated, there's going to be a lot of criteria that we will be judged by, I would say. In particular, given the ubiquitous nature, right, and the potential impact on the environment. One of the key technical challenges, obviously, is how do you improve the efficiency of these batteries in terms of how much energy they can store for a given unit weight, for example. And one of the big criticisms today is just how heavy these batteries are, what they've done for vehicle weight. And that's very analogous to the early days of the semiconductor industry, where power consumption was high, these chips were very big, and so it limited the application of the technology. And so one of the things that I wanted to maybe bring up and ask Brenda's thoughts on were, how do we leverage the innovation best practices from other industries? Has the battery industry been open to looking at other technologies and how they were able to accelerate innovation and looking for, as I said, techniques or best practices that they could apply within the battery industry?
Yeah, Greg, great question. So we, I have spoken to personally very, very, very large kind of traditional battery cell manufacturers, but also there's a plethora of startups out there. And recently in talking to the startups, the conversation immediately goes to where you were going, which is energy, cell energy density, increasing the safety and reducing supply chain resilience to very few countries because of the supply chain issues, but also, how do we rapidly deliver battery designs that meet these somewhat conflicting performance requirements like range, long life, high energy, reliability, cost, etc. Then you go talk to some of the more established ones, and they're talking about the traditional technologies that I think have been around in many of our industries, traditional electronic engineering, mechanical engineering, and kind of blurring of those two things to come together, where the startups are thinking outside in, the more traditional manufacturers are thinking about some of the tried and true environmental issues, but they go around it by looking at the original way they solved some of the problems they originally solved many years ago. And I would say technology like, do I understand how to digitally represent some of the things I have to design in early on in order to get the output that I'm going to need later? Things like digital twins are immediately where the traditional manufacturers go, but the startups are actually thinking about production quality, throughput, environmental concerns, sustainability. So they're thinking almost about the impact at the end. It's kind of interesting to talk to the two different parts of the industry, kind of where you were going, Greg, with some of the traditional.
But Brenda, that's great because, we've been in technology a long time, and it's been clear people fall in love with it and they get so focused on it. If I have this great technology, everything's going to be good. But, over the years, you kind of look back and say, well, what worked and what didn't? What really made the impact? Mm-hmm. My view of the batteries is similar to what semiconductors and other industries has been, is that production is where you make money, and production at a low cost is where you make lots of money, frankly, the volumes. So I think my focus would be flexibility needed in manufacturing to accommodate the rapid changes in technology and supply chain. So what do I mean? That sounds great, right? Think about batteries. We have from lead acid to alkaline to NiCads, nickel metal hydride was going to be this great stuff, right? Yep. Finally, about 30 years ago, lithium ion. And then maybe the future is going to be solid state or lithium metal. Mm-hmm. All those, and particularly going forward, need good coordination and communication between development, what's the future roadmap, manufacturing, and supply chain materials. So one example. Today, lithium ion is ubiquitous. Everyone uses it. Right? We're all using it. But it's only good. It's getting better. How? Through continuous improvement of that base technology. There's been some announcements that they finally got some batteries that maybe were good enough to power aircraft. How'd they do that? They actually coat the electrodes with niobium instead of nickel, manganese, cobalt, or the graphite, right? So where do you get niobium? Brazil and Congo. People have to think through these things before, right? I'm sure a lot of people never heard of niobium, and it's going to become, I guarantee you, a big topic. So production flexibility, being able to, let's say, move niobium into the production process, and supply chain, getting the niobium into your factory are going to be key.
So Geoff, where you were going on, I think where you started on the manufacturing process, which to me, I think is at the heart of this industry for the big or the small companies. I think, though, the other added dimension here is how do you put sustainability at the heart of your development and manufacturing process? And what I hear these particular companies talk about is how am I going to establish traceability and transparency along the value chain through a combination of how do I collaborate activities, but more importantly, what are the standardized new processes that need to be developed? What are the clear measures that are going to make a difference, which are maybe not the measures that I used to use? And this is from material sourcing to the chemistry research to large-scale industrialization, all at the lowest possible carbon footprint. Back to the how do you put sustainability into that process? And I think by these manufacturers, that when they start or they think about emphasizing sustainability and turning that goal into action, they'll be able to differentiate from their competition and get the money out of the governments, generate value while contributing to social and environment efforts, but also differentiating themselves with better product for the consumer. And so it is all at the heart of manufacturing, but I think you got to think broader than the traditional things, because I do think sustainability has to be designed in there. So
You're
a little bit of
right.
No, it's a very good point. And I think, particularly for technologists, right? Yeah. Again, in the semiconductor industry, initially, the roadmaps were exclusively technical.
Exactly.
Right? What kind of minimum dimension you would be able to, what kind of transistor densities could you achieve? And you're right, Brenda. I think sustainability, environmental impact, and, we have to be quite candid. There's a lot of concern, as Geoff brought up, over rare earth supplies and how they're mined, right? And so these are going to become very relevant to discussing how do we build a sustainable and responsible supply chain for the battery industry.
You know, what's interesting is the semiconductor industry is one of the few industries that was and is manufacturing defined. You define specific manufacturing nodes and processes, and whereas a lot of the other industries, automotive, aerospace, and defense, are design defined industries where you typically will design first, et cetera. And Brenda, you're bringing up like a third dimension now, right? Which is kind of this holistic aspect that's bringing in other pieces. You know, I was looking at also some numbers. Today, batteries, right, about 100 kilowatt hour type capacity in an EV that gets you 300 plus miles. They're produced at these gigafactories, right, that are 40 gigawatt hour capabilities. It's about 1,000 to 2,000 batteries a day kind of capacity coming out of there. So again, kind of like how we think about semiconductors and how many wafers you can get out. But certainly, you know, anecdotally, by the way, I recently installed solar on my house here in California. When I looked at the ROI for the solar cells, right, which is kind of a direct output of semiconductors, the break even was 4 years. When I looked to install a battery in, the break even there was over 20 years. So I actually decided not to install the battery. I did just solar cells. And, you know, fortunately, we have reliable energy out here, so I'm not worried about it as a backup. But
one statistic I saw said that 25% of the cost of a battery, lithium ion, is manufacturing cost. No, it's not the materials. It's just this. So anything that could bring that down would clearly help the implementation, the scale, and the penetration.
And the adoption. Then you'd get the adoption of Fram, who didn't totally.
Very analogous to semiconductors. That's why materials innovation is going to be critical. And if you look at within, you know, semiconductors, for example, what drove the ability of being able to be more dense in terms of semiconductors? Of course, it was, you know, smaller dimensions, but also new materials, right? That was key to enabling smaller and thinner dielectrics and conductors. You know, a big conversion, for example, in our industry was going from aluminum to copper for our wiring. Huge enabler. Likewise, I think for the battery industry, as Geoff indicated, you know, these new materials will play an important part in achieving, you know, the balanced goals that you described, Brenda.
All right, I'm going to kick it over to Brenda for final thoughts, Brenda.
Ooh, final thoughts. Okay, so final thoughts. So I would say we've talked about an industry that is exploding. And I think the thing that's really interesting about this industry is gigafactories, for example, that was previously mentioned. There aren't enough gigafactories today to produce the demand that's going to be needed in the next 10 years. That's the industry opportunity while it's a challenge. And I think where a lot of us went is we have to look at materials, we have to look at sustainability, and we have to look at accelerated battery manufacturing processes. You kind of got to look at all three over the umbrella of designing in sustainability in order to probably make this industry capable of delivering what the demand's going to be and tying those together. And it's funny, we've been talking recently inside of Siemens a little bit about how do you accelerate battery development? How do you do smarter battery manufacturing? And then how do you do advanced machine engineering and advanced material engineering for battery? And they kind of tie to those three things we just talked about, from the science in the beginning and learning from other industries. I think this is an industry ripe for innovation, but there's going to have to be a lot of collaboration and forethought gone in to think about the new impacts we have to deal with, like sustainability. Super exciting time, though, to be a battery manufacturer.
Very cool. Very cool. Well, we covered a lot today, and I want to thank Brenda, our newfound sister here. We're going to have to notify Dad, by the way.
That's okay. As long as there's a birthday gift in my future.
Absolutely. Absolutely. And we want to thank all of our listeners to Brothers Talking Tech. Please let us know what you think of today's session and what topics you would like to cover in the future. Goodbye, stay safe, and stay well.